Hi everyone, this is Kiranmai from H&S department. Today in this session, we are going to discuss about an intrinsic semiconductor. So coming to an intrinsic semiconductor, in this we are going to deal with what is an intrinsic semiconductor, and then we are going to derive an expression for density of electrons in conduction band, then density of holes in valency band. Then from those equations, we are going to derive an expression for carrier concentration of intrinsic semiconductor, and from that how a Fermi level varies with temperature. So for that, especially, what is an intrinsic semiconductor? Intrinsic semiconductor is nothing but an undoped semiconductor which is not added with any impurity. Such type of semiconductors which are pure in its form, such in semiconductors are called intrinsic semiconductors or undoped semiconductor or an I-type semiconductor. Hence, in these semiconductors, since there is no impure atoms in them, the completely its charge carriers depends on the material itself. Okay, so its electrical conductivity, it depends on its inherent properties only. The best examples for the pure semiconductor materials are silicon and germanium. Coming to its energy level structure, at 0 degree Kelvin, if you won't give any thermal energy to these materials, obviously all electrons will lie in the valency band, and all electrons will lie in the valency band, and an empty conduction band will be there. This structure is very similar to the insulators. Hence, intrinsic semiconductors at 0 degree Kelvin behaves like an insulator. So, but as the temperature increases, what happens? Slowly electrons in the valency band are thermally excited from valency band to conduction band, where those electrons become free and conductive. Hence, in the intrinsic semiconductor, due to thermal excitation, electron hole pairs will be created. So if one electron is excited from valency band to conduction band, means one vacant space called as hole will be created in the valency bands, which means that if an electron is excited to conduction band, a hole will be created in the valency band. Therefore, electron hole pairs are created in intrinsic semiconductor in equal proportions, which means that the number of electrons in the conduction band will be always equal to number of holes in the valency band. So for this, let's just see a energy band structure for an intrinsic semiconductor at two different temperatures, one at 0 degree Kelvin, another one is 3 degree Kelvin. So 0 degree Kelvin, since there is no thermal excitation, all electrons will be filled in the valency band, then there will be an empty conduction band separated by an energy gap. But as you increase the temperature from 0 to 3 degree Kelvin, what happens? Electrons in the valency band absorbs that energy, and they try to excite from this valency band, and they will get free in conduction band. So if this electron is excited to conduction band, means one vacancy will be created in valency band, which we call it as hole, and this number will be proportionate to each other. The number of electrons excited to conduction band will be equal to number of holes created in the valency band. So coming to the calculation of density of electrons, as we have to calculate two things. One, to find out the carriers in the intrinsic semiconductor, we should know how many number of electrons are there in the conduction band and how many number of holes are there in the valency band. For that proportionality, just consider uh, a semiconductor material which is having a conduction band extending from EC to infinity, a conduction band extending from EC to infinity. So this is a conduction band which is extending from EC to infinity. In this energy band gap, let us take a small gap of energy, that is D, which is from E to E plus D. We are just taking the small energy gap E to E plus D, and then we will, whatever the number of carriers we will get here, let the number of carriers in this gap will be Dn. So just integrating it from 0 to, sorry, EC to infinity will give you total number of electrons in this gap. Okay, understand? So for that, let us take Dn as the number of electrons with the energy gap E to E plus D. Then Dn can be written as dn will be equal to f of e z of e d, where f of e is the probability function and z of e is the number of states present in this gap e to e plus d. These are the number of different states which are present in the gap e to e plus d. This will be given, this number of density of states can be given by a function z of e d. When you multiply it with the probability function to be that state occupied is given by f of e. Now, to get the total number of electrons in the conduction band, just integrate dn from EC to infinity, from the minimum energy of conduction band to maximum energy of the conduction band, as the conduction band is extending from EC to infinity, and we have taken dn in an energy gap of d, which is extending from E to E plus d. So the total number of electrons n is equal to integral EC to infinity z of E f of E d. So what is Z of E d? Z of E d is nothing but the density of states whose expression can be given as 4 pi by h cube into 2m power 3 by 2 e power 1 by 2 d. This is an expression from density of states. Now for this, since the energy, since we are talking about the particle in periodic potential, so mass of the electron can be replaced as me star, where me star is called as effective mass. Okay, and the energy of the conduction band is starting from EC, so we are just replacing E with E minus EC power 1 by 2. These are the small changes what we had done in density of states, where mass is replaced with effective mass and total energy is replaced with energy starting with conduction band. And then coming to the another function, that is probability function, which gives that state to be occupied by an electron. The real one is 1 by 1 plus exponential E minus EF by KT. But when you compare this one, E is much greater than EF. So E minus EF will be much greater than 1. So you can neglect so the exponential E minus EF by KT will be much greater than 1. So you can neglect 1 from the denominator. So you are left with 1 by exponential f of E is equal to 1 by exponential E minus EF by KT. So now if you get this exponential function to the numerator, negative will be added, hence exponential EF minus E by KT. This is the probability function. Therefore, when you substitute the same thing in the total number of electrons with the z of e d and f of e, you'll get an expression like EC to infinity 4 pi by h cube into 2 me star 3 power 3 by 2 e minus EC power 1 by 2 exponential EF minus E by KT d. So just take 4 pi by h cube into 2 me star as a constant out of the integral. So left off with E minus EC power 1 by 2 exponential EF minus E by KT under the integral. Now just if you see this exponential function, if you write them separately, EF by KT will be a constant. So we are just getting this exponential function out of the integration. So left off will be exponential minus E by KT. This EF by KT will be a constant. So we are just got out. So n is equal to 4 pi by h cube into 2 me star power 3 by 2 e power EF by KT integral EC to infinity E minus E C power 1 by 2 e power minus E by KT d. Now in this, just keep this E minus EC as a constant x. Now if you get EC onto the other side, E is equal to x plus EC, then DE will be dx, because EC differentiation of EC will be 0. So differentiation of E is equal to differentiation of x. Now if you see about the integral limits, what are the integral limits we are having? Lower limit is EC and upper limit is infinity. Now substitute them in this expression. The value will be changed like EC minus EC, comma, and infinity minus EC. So this will be equal to EC minus EC is equal to 0. Infinity minus something will give you infinity only. So the limits are changed as EC infinity to 0 infinity. by substituting all those things, the equation will be changed like a constant 4 pi by h cube to me star power 3 by 2 exponential ef minus ec by kt integral 0 to 8 x power 1 by 2 e power x minus x by kt dx. This is a gamma function whose value will be equal to kt power 3 by 2 pi power 1 by 2 by 2. So just replacing this integral function with a gamma function, you'll get a final expression for total number of electrons per unit volume as 2 into 2 pi me star by kt, me star kt by h square power 3 by 2 exponential ef minus ec by kt. This is the final expression for density of electrons in conduction band. In the same way, we have to derive one more expression for the density of holes in valency band. How? For this, just consider a valency band which is extending from minus infinity to EV. In that, we are just taking a small energy gap dE, which is having density of holes as dP. Now again, taking dP value and integrating it from minus infinity to EV will give you total number of holes in that valency band. So for that reason, again, dP is equal to 1 minus f of e z of e dE, where 1 minus f of e. Why we have taken 1 minus f of e? Because f of e will give you the probability function for a state to be filled with electron. Then 1 minus f of e will give you for not filled by electron, which is nothing but occupied by a hole. So 1 minus f of e will give you probability of that state of energy E is occupied by a hole, and Z of E dE will be a density of states. Again, just taking the formulas into consideration and integrating them from minus infinity to EV, you will get the total number of holes in valency band. For that, again, Z of E dE is equal to 4 pi by h cube to m e power 3 by 2 e power 1 by 2 dE, where here the mass again in periodic potential can be replaced with effective mass of hole. So you can write it as mh star. In place of m, we just replaced it with mh star. And the total energy of the maximum energy of the valency band is ev. So the energy can be replaced as ev minus e, because the top of the valency band is ev. So by again probability function 1 minus f of e is equal to this one. Again, just by taking 1 plus x power minus 1, 1 plus x power minus 1, we can write it as 1 minus x plus x square minus x cube. Series will be there. Now in that series, we can write it as 1 plus x e power e minus ef. The 1 cancel, you are left with exponential e minus ef by kt. Now we had two expressions, that is density of states and probability function. Substituting it in the final expression, you'll get like this. Again, 4 pi by h cube 2mh star into exponential minus ef by kt. All these are constants. You just get them out of the integration. So left off with minus infinity to ev minus e power 1 by 2 e power e by kt dE. So again, keep ev minus e as x, then just getting ev onto the other side, you'll get ev minus x is equal to e. Differentiating it will give you dE is equal to minus dx. And the limits also changes from minus infinity comma ev to just taking minus infinity comma ev. That can be placed in the expression ev minus e. So ev minus e minus infinity comma ev minus ev. So the final expression will be minus infinity, sorry, minus of minus plus. So this will be infinity to 0. So the lower limit will be infinity, upper limit will be 0. So substituting them, you'll get an expression in the form of gamma functions. This negative can be changed by interchanging the limits as limits from infinity to 0 as 0 to infinity. So again, gamma function will be there. Keeping gamma function into the expression, you'll get a final expression for number of holes per unit volume in the material. So now we had the number of holes in valency band and also the number of electrons in conduction band. For an intrinsic semiconductor, we had one condition that number of electrons in conduction band is equal to number of holes in valency band, that is N is equal to P. So let it be equal to Ni, that is the carrier concentration of intrinsic semiconductor. So squaring of Ni square can be written as Ni into Ni is equal to Ni is equal to P. So Ni square can be written as N into P. Now just multiplying the density of electrons with the density of holes in valency band, we'll get a final expression as for Ni square. Now keeping EC minus EV as easy, you can get one expression. Just taking square from one side to another side will give you root. So square root of 4 will be 2. Square root of 2 pi by kt by h square whole cube will be equal to 3 by 2 me star power 3 by 4 exponential minus Eg by 2 kt. This is the final expression for carrier concentration of intrinsic semiconductor. Now from this, just derive an expression for Fermi level, that is Fermi energy. So that again the same condition, that is for intrinsic semiconductor, number of electrons in conduction band is equal to number of holes in valency band. Now on both sides you can cancel 2, and also you can cancel 2 pi, you can cancel kt. All these are constants which are same on both sides, h square. So you are left with me star power 3 by 2 exponential function is equal to mh star power 3 by 2 exponential function. Now just take exponential functions onto one side. You'll be like how it seems to be exponential ef minus ec by kt by exponential ev minus ef by kt is equal to mh star power 3 by 2 by me star power 3 by 2. So you can like it is like e power a by e power b. So we can write it as e power a minus b, that is ef minus ec by kt minus ev minus ef by kt. This is equal to mh star by me star whole power 3 by 2. So again in the exponential function, you can take kt as common. So left off with ef minus ec minus ev plus ef. This is equal to mh star by me star power 3 by 2. So again exponential 2ef by kt minus ec plus ev by kt is equal to mh star me star power 3 by 2. So this is like exponential a minus b. So you can write it as exponential a by exponential b. So this will be changed as exponential 2ef by kt divided by exponential ev plus ec by kt. This is equal to mh star me star power 3 by 2. Now if you get this denominator onto the side, this will be like exponential 2ef by kt, that is equal to mh star by me star power 3 by 2 exponential ev plus ec by kt. Now taking log on both sides, what happens? Log and exponential will cancel on the left hand side. On the right hand side, you will have log a into b. So you can write it as log a plus log b. So it will be changed like 3 by 2 log mh star by me star plus ev plus ec by kt. So just rearranging the terms, you'll get EF is equal to this one. So at if you assume ME star is equal to MH star, and at 0 degree Kelvin, EF will be equal to EV plus EC by 2. So for the Fermi level will be located in the midway of valency level to conduction level, where it is independent of temperature. So if you see the expression, uh, if me star equal to mh star, that Fermi level will be midway of EC to EV. conduction level to valency level. But if mu star is not equal to mu star, the Fermi level will be just shifting towards the conduction level. This is the variation of Fermi level with temperature. Thank you.